Hello students. In this video we're going to discuss scientific notation. Scientific notation is used to express very large or very small numbers and make calculations more manageable. It consists of a number between 1 and 10 followed by times 10 raised to an exponent. The exponent can be determined by the number of places you have to move decimal point to get only one number in front of the decimal point. And we can use scientific notation as a means of reporting answers to the proper number of significant figures. What does scientific notation look like? Well, here's a number that's in standard form, 24 trillion. If we were to convert this to scientific notation, it would be 2.4 times 10 raised to 13. Alright, the 2.4 is your coefficient, 10 is the exponential term, base 10, and 13 is the exponent or power in which that 10 is raised to. The exponent tells you the number of places in which you've moved the decimal point to get in scientific notation. So if we were to put a decimal point here in our standard notation, we move that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places between a 2 and a 4. Okay? So a number less than 1 reported in scientific notation, what does that look like? Well, here we have 0.000000458. Remember, leading zeros are not significant, so we're only going to focus on this 458. So if we were to report this in scientific notation from this current standard form, we'd move this decimal point 1, 2, 3, 4, 5, 6, 7 places to the right. So we report this answer in scientific notation as, or this number in scientific notation as 4.58 times 10 to the negative 7. Okay? Numbers less than 1 are always going to have an exponent that is negative. Numbers greater than 1 are always going to have an exponent that is positive. Okay? So always remember that. Another way to think about it, if I move this decimal point to the left to get a number in scientific notation, that number is greater than 1, so it's going to have a positive exponent. If I move the decimal point to the right to get in scientific notation, then that number is going to be less than 1, so it's going to have a negative exponent. Alright, so when we're converting from standard notation to scientific notation, we want to start with the number and move the decimal to the first non-zero digit and second digit. And we've seen that in the previous slide. The number of places you move the decimal point is the exponent value. Okay? And if the exponent is positive, the number is greater than 1. If the exponent is negative, the number is less than 1. So let's look at some examples. So pause the video and see if you could express these numbers in scientific notation. Okay, so hopefully you've paused the video and you've expressed these numbers in scientific notation and you've gotten them right. So let's see. Let's check comprehension here. So we have 99.343. So if we express this in scientific notation, we're going to move this decimal point one place to the left, so that's going to be 10 to the first, right? So that would be 9.9343 times 10 to the first in scientific notation. Alright, in this example we have 4,000.1. What would that look like in scientific notation? Well, we take this decimal point and move it 1, 2, 3 places to the left, so that will be 10 to the third. Okay, so that will be 4.0001 times 10 to the third. Okay, let's look at this one. We have 0.000375. If we were to report this in scientific notation, we'd move this decimal point. We would move this decimal point 1, 2, 3, 4. So that will be 10 to the negative 4 because we moved the decimal point to the right. So that will be 10 to the negative 4. So we would get 3.75 times 10 to the negative 4. Let's look at this one. This is 0.0234. So if we was to express this number in scientific notation, we'd move the decimal point 1, 2 places to the right. So that'd be 10 to the negative 2. So it'd be 2.34 times 10 to the negative 2. And finally, let's look at this one. This is 94,577.1. So to express this in scientific notation, we'd move 1, 2, 3, 4. So that would be 10 to the fourth. So that would be 9.45771 times 10 to the fourth. So hopefully you got those right. And kudos if you did. Alright, so now what we're going to do is we're going to go from scientific notation to standard form. So pause the video and see if you can express these in standard form. Okay, so hopefully you pause the video and you work through these and hopefully you got those right. So let's check comprehension here. Alright. So this is 3 times 10 to the 6. So to express this in standard form, we'd put a decimal point right here and we'd move it 6 places to the right because this is positive. So we would move it 6 places to the right and that would give us 3 million. Here we have 6.26 times 10 to the 9th. And so we'd move this decimal point 9 places, I'm sorry, to the right. And so that would give us 6,260,000,000. Okay. In this case, this is a negative exponent, negative 4, so we would put a decimal point here and move it 1, 2, 3, 4 places to the left, and so that would give us 0.0005. Here, again, this is a negative exponent, negative 7, so we move this decimal point 7 places to the left, and so that would give us 0.000000845. Here, this is a positive exponent, 3, so we'd move this decimal place to the right 3 places. 1, 2, 3, and the value goes to 0. So this would be 2,250. Okay, so I hope this video was helpful and happy studies.